Hi everyone, just doing a video because I realised on the Google Classroom that I did leave a rather nasty paper here. The rest are all pretty nice actually, as in, well, when I say nice, I mean reasonable. The CGP ones will be slightly easier than what you can expect. These ones from the actual textbooks we can't afford, they'll be about right, exactly right, I would argue, so they're really worth looking at. But this little one, which is titled 21A9 blah blah blah, it has some horrid questions. It really does. I was working on it after I was one of the students, Ashlyn, asked me basically to do some questions, and this one in particular I want to talk about because it's so nasty. It really is. And I'll do a few more from this paper happily. But what I would say is, I think that paper, this particular paper, it's not an example of what a normal paper looks like. It's an example of what a lot of really nasty questions look like. Now, there will be a really nasty question in your exams. There always is. But this paper, if you like, is really good practice for the really nasty questions, but it doesn't really practice so much of the basics. But anyway, let me help you out with some of it. So first question I quite liked, but I'm sure students would absolutely hate it because it's got arc sine x equals arc cos of y minus 2, and it wants you to prove this. Now, my thoughts were to immediately draw a triangle, yeah? And to think, okay, well, if we've got theta here, yeah, we could say that sine theta, well, that's going to be opposite over adjacent, isn't it? But I want theta to end up equaling arc sine of x here. So if I have the opposite as x and the hypotenuse as 1, did I say arc sine theta is opposite over adjacent there? I'm always saying incorrect things. I apologize. But sine theta is opposite over hypotenuse. So if I have this as x over 1, then I end up with theta is arc sine x. And the way you want to introduce this to the examiner is just say suppose, yeah? Suppose you have a triangle here that sine theta equals x, then theta is arc sine of x. And then for the cos of arc cos of y minus 2, well, let's have cos theta is y minus 2 over 1, because then I'm going to have theta is arc cos of y minus 2. And so I've sort of like artificially manufactured a situation, if you like, where arc sine x equals arc cos of y minus 2. So I can say, so arc sine x equals arc cos of y minus 2. And if I look at this, we can see from the diagram, we can have x squared plus y minus 2 squared is 1 squared. Pythagoras is going to help us now. And then if you multiply it out and simplify, you're going to have x squared plus y squared minus 4y plus 4, but then take away the 1, you'll have plus 3 equals 0. And so k equals 3. And that's it. Yeah, bit of a weird question to start with. That really weird, but there we go. That's that was the way I chose to do it. I wonder if you could do it by this is really subtle, by differentiating both sides. But no, don't try that. That's a crazy thing to do. Okay, what have we got here? Apologies for the screaming. I don't know what they're screaming about. I really don't. Okay. Yeah, I thought this one was pretty tricky as well because the way I'm going to do it anyway is quite subtle, I would say. I'm thinking, okay, if we're given this, let's prove that this is true for all real values. So I'm going to firstly multiply out the right-hand side. And then with the right-hand side, did I say multiply the right-hand side? Multiply the left-hand side. And then with the right-hand side, I'm going to change that 2 sine x cos x into sine 2x. Because I know that sine 2x is trapped between 1 and minus 1. Now my strategy here is I'm going to turn this into a perfect square. So I want to move the 8x over. Yeah. And if I want this quadratic expression to be a perfect square, then it would be lovely if I had 36 here. Yeah. So what I'm going to do is I'm going to add 32 of the 33, leaving 36 there. And then I've just got 1 plus sine 2x. Now you might think, how did you know to do that? Well, it's because if I can write something as a perfect square, I then know that it's 0 or bigger. Yeah. And this is trivially true, this last statement. Yeah. So what I can say now, clearly, this is true as the left-hand side is greater than or equal to 0, and the right-hand side, well, sine 2x is trapped between 1 and minus 1, isn't it? The right-hand side is also going to be greater than or equal to 0. Now, I suppose I just need to tackle the possibility that the left-hand side equals the right-hand side, i.e. they're both 0. And I'm just going to tackle that possibility by pointing out when left-hand side equals 0, right-hand side doesn't equal 0, yeah? And that's because the left-hand side equals 0 when x is 6, as x equals 6, and then the right-hand side will equal 1 plus sine 12, and sine of 12 doesn't equal 0, yeah? And so I've proved it, yeah? I can now just write, hence the result is established. And I'm going to write down what we initially started with is strictly greater than 8x minus 33 plus 2 sine x cos x. There we go. Okay, part B, you're given the following information, yeah? Okay, so we've got x plus mod y equals 6. My initial thoughts are, as x is definitely a positive integer, but y is a member of the reals, let's think about x, yeah? Well, x equals 6 minus modulus of y. Alternatively, I could rearrange it as modulus of y equals 6 minus x. And actually, it's this format which tells me a lot about x. I think then that x can only be 0, 1, 2, 3, 4, 5, or 6. Yeah, those are the only possibilities for x. And that's just because the left-hand side of this is strictly 0 or bigger because of the modulus. And we're taking away a positive integer. And so those are the only positive integers we can take away and end up with a result which is 0 or bigger. So when I'm doing the proof by exhaustion, which is where you do all possible cases, I've only got to consider these cases. So I'm just going to point out that 0 times by y. Oh, by the way, when x is a positive integer, we can now work out the y values, yeah? I can say, so y equals, because remember, x plus the mod of y equals 6. Now, if x is 0, y could be 6 or minus 6, yeah? And I have to work out all the pairs for these ones. Let me write it down like this. X equals 0, in which case y equals plus or minus 6. X equals 1. In which case y equals plus or minus 5. And that's because if x is 1, yeah, y could be 5, but it could be minus 5 as well, because 6 minus the mod of 5 and 6 minus the mod of minus 5 is still 1. I'm going to put dot, dot, dot here, going all the way up to x equals 6, and then y equals 0, yeah? So if I'm going to do a proof by exhaustion, I just need to show that the product of these is always between 10 and minus 10. So I'm just going to point out 0 times plus or minus 6 equals 0. 1 times plus or minus 5 equals plus or minus 5. 2 times plus or minus 4 is plus or minus 8. 3 times plus or minus 3 is plus or minus 9. 4 times plus or minus 2. This is what a proof by exhaustion is like. It's exhausting. 5 times plus or minus 1. And then 6 times 0 is 0. Hence, let's just put this in. Hence, for all possible values of x, xy is stuck between 10 and minus 10. There we go. Done. Okay, the last one, the one I really wanted to do was this one. And the reason I really want to do it is because I found it so difficult. It is horrible, this question. It really is. If you had this in exam conditions, I think it's damage control. I really do. You know, it's one of those things where it's hard in exam conditions. Of course, you will all be getting full marks on it because you've worked so hard. But, you know, what I'd say on these kind of questions, where are super difficult, is just try and get some marks, you know. Getting 50% on the most difficult question of paper is actually a fantastic result. Yeah, remember, like in recent years, it's been about 55-60% for an A star, sorry, an A, and like for an A star, it's been about 75%. Well, I would argue if you're getting most of the paper correct, and then on the most difficult question, you're only getting 50%, that's actually a really good score. That's typical of a very good candidate. Okay, so what have we got here? It doesn't start off too bad, actually, because it starts off with parametric equations, and it wants you to find a Cartesian equation. And there's a very standard approach for this. If you arrange this one into x minus 3 over 2 root 3 and rearrange this equation into y minus 5 root 3 over 2 root 3, and now use the fact that sine squared t plus cos squared t is equal to 1, you can get the answer quite quick, because we're going to get y minus 5 root 3 squared over 12 plus x minus 3 all squared over 12 equals 1. And that's just 2 root 3 squared is 12. And so you end up with their answer in the next line. And we'll flip it just so it looks like their answer. Okay, and that completes the proof, yeah? So that was nice and easy. The next part's pretty difficult, though, to be honest. And it's difficult because you've got to consider, and they could easily do this, but I just hope they wouldn't do this as well as all the other nastiness in the question. Like, I don't mind a nasty question, but it's where it's packed full of nastiness, and also there's not enough marks for some of the answers. Okay, so let's talk about the range of x and the range of y. Well, naturally, the range of x is going to be dependent upon the values of t, and t has been restricted. So what I'm going to do for x and for y is I'm going to draw a little sine curve and a little cosine curve between these values. Let's talk about cos first. Now, if t is going between minus pi over 4 and 2 pi over 3, they've picked some really horrible values there, haven't they? It's going to be going from there to about there, yeah? Now the maximum value, if you think about it, when we're trying to find if we're trying to find the range of x, it would be useful to know the maximum value of x and minimum value of x. Well, a maximum value x can be is going to occur where cos t is as big as possible. And cos t in this range takes a value of 1, yeah? And so I can say the max x is going to be equal to 3 plus 2 root 3, yeah? Because the maximum value of cos t is 1. But what about the minimum value? Well, the minimum value of cos t, normally it's minus 1, isn't it? But it doesn't get there in this range. And so you're going to have to use minus a half. And that's just because cos of 2 pi over 3 is minus a half. And so if we have minus a half in here, we're going to have min x is 3 minus root 3, just because minus a half times 2 root 3 is minus root 3. Okay, so that's how I've done that. I'm going to use exactly the same approach for y, but this time I'm going to need to sketch the sine curve between those values. So the sine curve between those values looks something like this. Yeah, that's kind of upside down version of what we had before. But at minus pi over 4, sine is actually minus 1 over root 2, or minus root 2 over 2, as your calculator will tell you. And then the maximum value, because I'm interested in the min and max here, it's still going to be 1, yeah? And so for y, which is, let me just move the screen over so you can see it, for y, which is this equation, where's my highlighter? Oh, that's the rubber. For y, which is that equation there, if I want to know the max y, well, that's just going to be replace sine t with 1, so you get 5 root 3 plus 2 root 3, which is 7 root 3. But the min y is going to happen at minus 1 over root 2. And if you do, make minus 1 over root 2 minus root 2 over 2, it's easier to do the minus root 3 minus root 2 over 2. It's easier to do this, because the 2's are going to cancel, and you're going to end up with 5 root 3 minus root 6. Cool. And so I've got the range of x and the range of y. You might want to write it like this at the end. 3 minus root 3 is less than or equal to x, which is less than or equal to 3 plus 2 root 3. And then, similarly, 5 root 3 minus root 6 is less than or equal to y, which is less than or equal to 7 root 3. Yeah? Okay, nasty question, I'm sure you'll agree. Well, 2 marks for that. That was a lot of hard work for 2 marks. It gets worse. I wish it got better, but it gets worse. Now, we've got to find a line with equation y equals mx plus 12 root 3. It intersects the curve. State the range of possible values of the gradient using set notation for your answer. So like 12 root 3 is basically about up here. And so y equals mx plus 12 root 3 will be basically sort of going maybe like that, but maybe it's going like this, yeah, and just touching it like there. All values of the gradient in between those will be possible answers, yeah? Now, we can easily find this coordinate here because of the work we just did, yeah? The work we just did established the minimum value of x was 3 minus root 3. And I don't know if you remember, but that occurred when we were at minus a half. In other words, when t was 2 pi over 3. In other words, at that point, t equals 2 pi over 3. Yeah? And so what I can do is I can work out the actual coordinate by plugging in t equals 2 pi over 3. We get the x as 3 minus root 3. We already know that. But we're not sure about the y yet. And if you chuck in 2 pi over 3, sine of 2 pi over 3 is the same as sine of pi over 3. That's sine 60. It's root 3 over 2. And so the 2's are going to cancel, and we're going to end up with 3 here, and 5 root 3 plus 3 there. I think that's right. I'm doing a lot not on my calculator at the moment, and this is where it went wrong when I did it on the board with Ashlyn. So, yeah, let's try and get this right. I'm just going to check my maths there. Sine of 120, 3 root 2, multiplied by 2 root 3. Oh no, yeah, multiplied by 2 root 3, 3, and 5 root 3 plus 3. Yeah, it looks good. Okay, so what are we going to do here? Well, if we're going to find the gradient from this point to this point, which we've now discovered, the gradient m, and this is the like most negative value of m, if you like, is going to equal the change in y, which is 12 root 3 minus 5 root 3 plus 3, over the change in x. Change in x is easy because it's just 3 minus root 3. And so m equals 7 root 3 minus 3 over 3 minus root 3. I might quickly see if I can simplify that. Just doing it on a calculator, sorry. Over 3 minus root 3. Cool, I get 2 plus 3 root 3. Okay, I think that's my minimum value of m, yeah? Min m equals 2 plus 3 root 3. I'll put it in set notation at the end. Let's find max m now. Now, max m is going to occur where this line is tangent to that curve. And really, the best way of doing that is to actually look at your Cartesian equation and plug in this line into the Cartesian equation, and then make sure that it's only got one repeated root using the discriminant. So that's what I'm going to do. So I'm going to plug in. See what I mean? It's a long old question, this. It really is a long old question. I'm going to plug in. Well, firstly, let me multiply it out. I get x squared minus 6x plus 9 plus y squared minus 10 root 3y plus 5 times by root 3, well, 5 root 3 all squared. You're going to get 25 times by 3, which is 75, I think. And then that equals 12. Cool. Okay. Right. This is good. Let me just check something. 5 root 3 squared. Yeah, it is. I thought it was 75. Okay, so what am I going to do now? I'm going to plug in my y equals mx plus 12 root 3. Yeah? And then I'm going to try and ensure that it's definitely got a repeated root. So x squared minus 6x plus 9 plus, now let's just square this straight out. I'm going to have m squared x squared plus 24 root 3 mx. And then plus, now that's going to be a 12 root 3 all squared. I think it comes to like a, what does it come to? 432. Okay, then I've got minus 10 root 3 times by mx plus 12 root 3. Such a nightmare, hey? And then plus 75. And I tell you what, let's actually on this line simplify. 9 plus 75 is 84. Take away the 12, we've got 72. Yeah, so I've already dealt with that. equals 0. Okay, so now I can actually write it in a format like this. X squared m squared plus 1. So I'm collecting together the x squared terms, yeah? And then I'm going to collect together the x terms. I'm going to have 24 root 3 m. Oh, but minus 10 root 3 m, so that's just 14 root 3 m. And then I've got a minus 6. I think I've dealt with all the x's then. And then I've got 432 plus 72 minus 100 minus 360, because that's going to be minus 360. So 432 plus 72 minus 360. Would advise you not to do what I did, which is try and do this on a calculator, without a calculator, sorry. I ended up in a pickle. Okay, right. Now, we're going to use b squared minus 4ac equals 0. Because this line should be tangent to the curve, I want to find a condition on m for that line being tangent to the curve. So b squared minus 4ac equals 0. So that's 14 root 3 m minus 6 squared minus 4 times m squared plus 1 times by 144 equals 0. Okay, after you multiply that out, you're going to get 14 root 3 squared, 588 m squared, oh, minus 4m squared, which is 584m squared. You're then going to get minus, right, 6 times 2 times 14, minus 168 root 3m. See why I don't like this question? Oh, it's so annoying. And then we're going to have at the end plus 36, but then minus 4 times 144. So I'm just working it out. You get minus 540 equals 0. I think at this point I'd probably just use a calculator to solve this particular particular problem. I can't remember exactly what the I haven't actually got a calculator. Can I ask Danielle? Danielle, have you got a calculator that solves quadratics? Could you just put in 584 for A, minus 168 root 3 for B, and minus 540 for C? So yeah, 584 for A, minus 168 root 3 for B, and then negative 540 for C. 540, yeah, negative 540. Sorry, I'm just asking an assistant to, just because I looked at that quadratic and I thought I'm losing the will to live. Okay, did it not give you a nice answer? Okay, I was expecting a nice answer there. Let me just check. 584 minus 168 root 3. I think this is right. Why did I put in 2 decimal places? Delete. Okay, yeah. Yeah, I think I've made a mistake here. Let me just quickly go back up in my working. Sorry, Danielle, you keep doing with your, you keep working on your work. Okay, so where have I made my careless blunder? Oh, it's so annoying, like it really is. This is not a nice question. So let's have a look. I like that bit. That's cool. B squared minus 4ac. Was it somewhere earlier? No, that looks good. Okay, I'm just going to pause this for a second while I quickly check. Okay, I've just realised exactly what I've done wrong. It's a minus 4m squared here. It should be minus 4 times 144m squared. What a loser. Okay, so what we would have had is 588m squared minus 576m squared, which I think comes to 12m squared if you do that carefully. You just get so fed up with doing this, you try and rush it, and then you make a mistake. Minus, now I think that is going to be minus 168 root 3m. And then I'm going to have on the end minus 540. Oh, 576, but oh yeah, but then I've got a plus 36, so 36 minus 576. I think that minus 540 is correct. That's the thing. I try and do these things. I like not working with a calculator, but then you just end up making a mistake. Okay, so we end up with m squared minus, now 168 is divisible by 12. 14 root 3m. You'd probably just do this on a calculator low at this time. Minus 45 equals 0. And then finally, you can solve that using standard method. And I think it comes to m equals minus root 3, I believe. It's definitely going to be a negative gradient, but just check that on a calculator. But yeah, you should get that as your answer. Okay, so that finally allows us to write this in set notation. Yeah, because the max m. Oh, and by the way, this should have been negative. Yeah, sorry, I haven't told you that before, but this should be actually negative just because I didn't actually take the full overrun. I did rise overrun, and so yeah, that should be actually negative. Okay, so right, what is our final? Then therefore, minus 2 plus 3 root 3 is less than or equal to m, which is less than or equal to minus root 3. And then to put it in set notation, just put m such that at the start and put it in curly brackets. Or you can use some Boolean algebra. There we go. Okay, finally, I just want to do the last little bit of this question. Find the largest possible area of a triangle and the smallest possible area of a triangle if P, 0, 0, and 0, 12 root 3 form a triangle. Well, let's draw this out again. I've got some nice arguments for this, I think. Okay, if we've got something like this, P lives somewhere on here, yeah? But we're doing the triangle from 12 root 3 to 0 to P, yeah? Now, if you think about it, the smallest triangle is definitely going to occur here because the base isn't changing. All you're changing is the height of your triangle, yeah? And that's what's giving you different areas, yeah? So the largest area is going to occur there as far to the right as possible for the maximum value of x. That's going to occur at max value of x. And this is going to occur at the min value of x. So here's where we can use our previous answers to find the area of the triangle. And that's just because the area of a triangle is just going to be done with a half times by the base times by the perpendicular height. And that's why I can just use the x coordinates. Half times by the base times the perpendicular height. So for part 1, I'm just going to need to do a half times 12 root 3 times by the min value of x, which I think was 3 minus root 3. And then I can just work that out. So I'm going to do that, 6 root 3 times by open bracket 3 minus root 3. Okay, I get 18 root 38 minus 18. And then here I'm going to get a half times 12 root 3 times the maximum value of x. What was that? Maximum value of x. Maximum value of x was, where is it? I think I've already rubbed it out. Oh, it's over here, 3 plus 2 root 3. So I can just do that times by 3 plus 2 root 3. And that's going to give me, let me quickly check on my calculator, multiplied by 3 plus 2 root 3. Okay, I get 36 plus 18 root 3. And there we go. That's the smallest possible area triangle and the largest, but done in the other way around. Yeah. So swap those over. But yeah, hope that makes sense. Let me quickly check my answers. Yeah, good. I got them right. It's that middle bit, though, the maximum gradient and minimum gradient. It's really, really, really annoying. It's just got the worst numbers in the world. And I strongly suggest to you that relying on a calculator there will be definitely the way to go. Otherwise, it just gets really, really annoying. I'll happily do some more from this practice paper. This practice paper definitely has a load of fiendish questions, so bear that in mind. Don't treat it as something which is likely to be exactly like your paper. You're better off thinking of it as a great place to find very difficult questions. But yeah, don't let it stress you out if you're finding it really difficult. I definitely found that middle question really, really stressful. And in exam conditions, I'd probably mess it up. But yeah, okay. Hope you found that useful. And yeah, keep up the hard work. Bye-bye.